Welcome to the video documentation of the Nixie Healer project. This is an example of a good Nixie tube. And this one is bad, but it can be healed to look like the first one. It is done by doubling the nominal current of the tube for a few hours. Then the tube is fine again. The Nixie Healer is able to automatically detect and heal Nixie tubes. How it works is explained in this video.
Now we will be talking about the hardware that we created for this project. So in principle, we created two printed circuit boards, and we will start with the more easier one, which is called Nixie socket PCB. It basically just consists of a lot of the footprints for different Nixie tubes and a connector that will later be put on the Raspberry Pi. So if we change to the 3D view, we can see a preview of the board, which you can see here. Like this. And there are the sockets for the different Nixie tubes. So for the other PCB, I will now talk about what it consists of. So most important is a high voltage power supply that we have here. We also have a fuse and the DC jack, and we have a digital potentiometer, which is used to set the output voltage of the boost converter. Besides from that, we have two shift registers. These are used to control which number of the Nixie tube should be lighting. With two shift registers, we could switch Nixie tubes with a maximum of 16 numbers. From the shift registers connected is always a transistor, which then switches on or off the Nixie cathode. And then we have some measurement stuff. So here we have a simple voltage divider for the voltage measurement. Then we have a DAC, because unfortunately the Raspberry Pi does not have a DAC or ADC. And with the DAC that you can see here, we set a voltage output, which is then used to drive a transistor. And this transistor is regulating the current that is flowing through the Nixie tube. Over here, just above the transistor, you can see that we have a shunt resistor that we use for a current measurement later on. And the current measurement then also has to be passed to the Raspberry Pi, which is done with the help of this ADC here. And furthermore, we also have the voltage measurement here. And now let's take a look at the board. As you can see, it is very compact, and it is a 4-layer print. And over here is the connector that will be stacked right onto the Raspberry Pi. And over here is the connector that will go to the additional board that I showed you in the beginning.
Here you can see the housing that we cut out of wood for our project. So if we take off the top cover and look inside, we can see the different components. So over here you can see the PCB with the different sockets that is at the back of the box. And before it, here we have the camera that has now with this nice box a fixed distance. And the other PCB, which is this one, is stacked onto the Raspberry Pi, which you may see over here. And also here is the display. And with this setup, we now have a fixed ambient lighting, fixed distance, and also the black painting helps to remove excess light from outside. And so normally this is closed, and you can easily get access to the tubes by opening here the back door.
And now we come to the software section. At first we clear the output and all variables. Then we connect to the Raspberry Pi via the network. Afterwards we start the initialization of the hardware. It is worth to mention that the camera is set to a fixed FPS mode to get equally bright pictures. The camera is operated in RGB mode. This can be seen in this and in this line. Now the nominal voltage is set to 170 volts and the current through the tube is defined to be 2.5 milliamp. Both values are applied by using the digital potentiometer and the DAC. Now the boost converter is running and set with the correct values. The first number can be activated on the tube. A picture of every number is shot in this section and saved for later use. At this point the tube is no longer needed and is shut down. During the on time of every tube a current measurement is done and now transferred to the Raspberry Pi to be used at the GUI. This section is where the magic happens. The saved images are loaded and converted to grayscale. Now bright pixels will be shifted to be completely black and all other values will appear white. Now the numbers of black pixels is counted and with this information a percentage of how healthy the tube is calculated. This information is also transferred to the Raspberry Pi. Now the picture of the tube is compared to a reference picture. This is done by using the SAD method which we discussed in class. This is done to make sure the right number is detected. The result of this will be the title of the figure. After all of this processing, the healing process of the tube can be started. If healing is necessary, the tube will run with twice of the current for about 2 hours. Afterward, this code could be run again to see if the healing was successful. Finally, the script will start the GUI at the display of the Raspberry Pi.
So now we go ahead with the GUI Python code. As you can see, here we first importing some stuff like packages and libraries, and then we go ahead, we have some variables like upper threshold and lower threshold. That's like come a little bit later in the color section. Then we have here some general display settings like background color or full screen stuff. And then we are loading here the current, the voltage and the brightness values from MATLAB, and also the pictures we made also from MATLAB. And here we are dividing our screen into some frames. Then here we have some give them some labels where we say if we show each picture for each number, so we can display the image. Then next to it we show the current to the screen. Also here for the 10 numbers from 0 to 9. Then we are showing the voltage here. And here we are showing the brightness of the tubes in different colors. So if it's perfect, if the figure is perfect, we show the green number in green, lit from the upper threshold to the depending on the threshold values. And if it's less than the threshold but also okay, then it's orange. And if it should be healed, then we putting it in red, the percentage value. And this also for each number. And that's the GUI code.
Now it's time for action. We come to the fun part and see the system working.